Press that button. Press over here. Get up the Vimy. Okay, so what we're doing is we've actually done a fair bit of optimisation already, and we've done it when we were doing our quadratics unit. And you might remember optimal solution just means it's the best possible outcome. So it might be we're making the most profit. It might be we're using the minimum amount of materials needed to design an enclosure. So that's what we're doing here, but we're going to use calculus methods. That's the difference. So I'll log on to Wiki. Did it 1 to 11? 13. Okay, so this is 15F, and let's just have a look at question 1. A manufacturer makes X items per day. The profit function is P of X equals minus 0.022X squared plus 11X take 720. So what we have here is the profit function. And the amount of profit they're going to make depends on how many items they're making. Find the production level that will maximise profits. So let's follow our process. Find f of x, done. We don't need to do that, it's given to us here. Differentiate. So we've got to find p dash of x. And so if we're going to differentiate this, we'll get minus 0.044x plus 11. Okay, and draw its sign diagram. So that means I need to find the root of this, what's going to make this equal to 0. So that's when $250. So what that means is when we make 250 items, that's when we have our root. Now obviously, okay, if we're thinking of the sign diagram here, we're talking about making X items, all right, which means we're only considering positive values. We're not going to make negative items because that doesn't make sense in the context of the problem. We have our root at 250, and it's the equation of a line, and it has negative slope, which means it's going down like this. It's going from the positive to the negative, which means we have a local max at 250. Okay, we've learned that skill now. This is the sign diagram of P dash of X. The profit is increasing until we get to 250, and then it starts decreasing. Now, does it say find the corresponding profit? No. Okay, all it says is find the level that, find how many items are made. So I might just graph that function really quickly. 022 plus 11x. So here's the function, and I'll just talk about it. So we have to make X items per day, and on the y-axis we've got our profit, and on the margin here we've got, on the x-axis we've got how many items we're making. So if we make just under 80 items, we're going to break even. We're not going to make any profit. We haven't quite made enough items. If we make 250 items, that's going to maximise our profit. If we make more than that, it's going to decrease our profit. You might go, why would that be the case? It could be something as simple as you need to maintain the machines. And if you make more than 250 items, the machines start to deteriorate quicker than they should. So 250 is going to give us the optimal solution. Okay, let's move on to number 2. A duck farmer wants to build an enclosure, rectangular enclosure of 100 metres square. The farmer must purchase wire netting for the 3 sides, as the 4th side is an existing fence. Naturally, the farmer wishes to minimise the length of fencing required to complete the job, so we're looking for a minimum solution. Part A, if the shorter sides have a length x, show that the length required of wire netting is 2x plus 100 on x. Find the minimum value and sketch the optimal solution. So, here's a white. Now, is anyone still writing down the first part? You haven't written it yet? So, we've got a duck enclosure and we've got an existing fence. So we're starting to get pretty familiar with these problems. It's like the chicken run that we did back in year 9. We've done a bit of it this year when we talked about quadratics. And it says the shorter sides. So these are going to be the shorter sides, and these have a length of x. And we don't know what this one is. Okay? And the area is 100 metres squared. So let's just call this y. Okay? Now, the area is equal to x times y. The area of this rectangle is x times y. But this is equal to 100. Alright, so we've got xy equals 100, which means y is equal to 100 on top of x. Okay? And then the total length of wire that we need is going to be, so that's our length of wire function, is x plus y plus x, the total perimeter of this fence. So we'll get 2x plus 100 on x. Okay, that's our L of x function. Okay, using the calculus methods, we find the function, we differentiate it. So we're going to look here, we're going to differentiate it. Before we can, we need to express it all at the top as a power of n. So that's still L of x, and then we're ready to L dash. Okay, now we need to find the root. So I'm going to, it's good we're doing this together because I'm going to go through some of the algebra with you. There are ways of just drawing the graph of this and getting the sine diagram. In fact, maybe we'll do that, and so I just show you how you can use technology to support you. So let's say we've found L dash of x, and I'm just going to say, well, let's just graph that function. It is to take 100 x to the power of minus 2. Alright? And now we're considering positive values of x, okay? Because again, we're talking about the length of something. We can see, I'll just change the window a fair bit. So let's go from to 20, and for y, let's go to 10, 5, and for y being minus 50. There we go. Okay, so we can sort of see it there. We're only considering the positive values. Remember, this is L dash of x. So this is the sum. I've just sketched this function. And so we're considering positive values. And you can G-solve the point of intersection on your calculator. And you'll get, what's that? 7.071. Okay? And we can see that it's negative and then positive. So we have a minimum solution when x is 7.071. Okay, let me show you how we're going to do that algebraically. What we're doing is we're finding when 2 take 100 on x squared equals 0. Okay, that's what we're trying to find. What I would do is move the 2 over the other side. So we're going to have minus 100 on x squared equals minus 2. We can get rid of the negative. So we've got 100 equals 100 on x squared equals 2. We can move the x squared up here. So we've got 100 is 2x squared. Divide both sides by 2. and then square root of x is the square root of 50. The square root of 50 is that 7.07. Okay, let's make sure we're answering your questions. So, part A, show that, find the minimum length of L and the corresponding value of x, okay? So when x is the square root of 50, we need to find L of the square root of 50. Now remember this L equation, this tells us the length of fencing needed, okay? So depending on the x value, the length of fencing is going to change. We're saying, well, the minimum length of fencing occurs when x is the square root of 50, so what is this minimum length of fencing? And so it's 2 times the square root of 50 plus 100 on top of the square root of 50. We'll just get it to a few figures. Root 2, 28.3, and then the unit is meters. And then you can sketch the solution. So if we were to just label this diagram, x is 28.3. Okay. The value of y is 100 divided by 28.3. So we'll put that in. And I've got 3.54. Okay, is going to be our sorry. This is the length of fencing we need. The value of x is 7.071. X is 7.071. Y is 100 divided by 7.071. 13.
So you don't need to do that middle part.
This part here? Yeah, so this is a very important skill to have, particularly if we're going to go to maths in year 12. All right? But I'm just pointing out how we can use our calculator to support us. So this is probably like a 5-mark question, and this is the process you're expected to do. But the point is, even if you can't do this, you can get the solution using technology, and you can still get your marks for this part and for this part. Okay, so it's about using, not relying on your calculator, but using it to help you. Okay, so let's move on. We might skip 3 and let's go to 4, I reckon. So radioactive waste is to be disposed of in a fully enclosed lead box of inner volume 200 centimetres cubed. The base of the box has dimensions in the ratio 2:1. So let's draw our diagram. Diagrams are helpful. Is anyone still writing any of this down? So, should we put the AC on? Anyone a bit warm? Yeah, I'm a bit warm. There it is. X, H. Now it says the edges are in a ratio of 2:1. So that means this length is twice this length. So here we're going to have 2x. Now, the volume of this shape is going to be 2x times x times h. Length times width times depth. So we've got 2x times x times h. That's 2x squared h. Now, part A. Show that x squared h equals 100. Well, we've got the volume is 2x squared h, and we're told that it's 200 centimetres cubed. It says that in the question. Volume is 200 centimetres cubed. So therefore, x squared h is going to equal 200 divided by 2, which is 100. Okay, show that the area, the inner surface area of the box is given by, and we have an equation there. So if we think of this box and its inner surface area, I'll just draw these dotted lines here. We've got, and so that means you're inside it, and you're talking about, it's like this room. Okay, so this room's a perfect example. You've got both walls, the floor and the roof, and then these far walls as well. So what the surface area is going to be then, is it's going to be, let's think about the front and the back. Okay, the front is 2x times h. Alright, so 2x times by h, and we've got two of them. We've got the front and the back, so we can change it to be 4xh. Plus, we've got two walls on the side, and they are x times h. So we've got xh there, and xh over here, so plus 2xh here. And then, the bottom is 2x times x, and so this is the top. So we've got 4x squared. Alright, we've got 2x squared at the bottom, 2x squared at the top. Yep. Okay, we can collect these. That's going to be 6xh plus 4x squared. Okay, now let's come over here, and we can just, we're looking to get it all in terms of x. Alright, so that means we're going to want to get rid of this h, or we're going to want to substitute h. So this equation here we can actually write like this, 100 on x squared. And then we have an equation for h only in terms of x, and that's what we're going to substitute in here. So we've got 6x times 100 on x squared plus 4x squared. And so we'll get 600 on x plus 4x squared. Okay, 6 times 100, x at the top, x at the bottom will cancel, we're left with one lot of x. And that's our surface area equation. Four x squared plus 600x, excellent. Okay, find the minimum inner surface area. Okay, so that means we need to, so we've found our function. The next step, find the surface area derivative. So before we can do that, we need to express everything at the top of the fraction. Okay? Alright, so here's where you could leap in and get the sign diagram from your calculator. Let's do it manually. We've got to find when the derivative is 0. So that means we've got minus 600 on x squared plus 8x is 0. Okay. Now what we want to do when we get a question like this is we want to get rid of this denominator. So what we're going to do is multiply both sides by x squared. So I'm going to multiply here by x squared and multiply here by x squared. What that's going to do is it's going to cancel this denominator because it goes to the top, and we've got x squared at the top and the bottom, so that cancels. We've got minus 600, and then here it's going to become 8x to the power of 3. Over here is just 0. All right with that? Cool. So then we've got 8x to the 3 is 600. We'll divide both sides by 8. 150? 75? And then cubed root both sides. Okay, now I might just show you this here. You can think about it in terms of cubed root. You can think about it like this. We're putting both sides to the power of a third. Okay, that's what we're doing when we perform the cubed root. And so here we're left with x and the cubed root of 75. .22. Okay. So that's probably enough from me. I can do another one if you want, or have a breather. Have a go yourself. So what didn't we do? We did 1, 2 and 4. So I'd probably skip 3 to be honest. We won't give you one like that. So have a go at sort of 5, 6, 7. They're the sort of problem solving. To develop the equation a bit. That sound good? Cool. Let's give it a crack. Obviously I didn't finish this one. I didn't go and finish it, but you've got the x value. Then it gets you to go say, what's the dimensions of the box? What's the volume of the box? You can figure all that out because you've got the value of x. All right. You can figure out what h is because h is 100 divided by x squared. So you've got all those dimensions. Now just in terms of dimensions as well, like dimensions would be length times width times depth. So if it asks for the dimensions, that's the statement you would need to make.